In this video, we will be talking about how to identify, add, subtract, and multiply complex numbers. To simplify the square root of 100, the answer is going to be 10, and the reason is because 10 squared gives you 100. So you're looking for numbers that are perfect squares. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. These are what you would call perfect squares. Now, if you were wanting to simplify a number that is not a perfect square, for example, 72, you could do it by simplifying, meaning what number goes into 72 that is a perfect square. So if we keep going on, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. So if you think of what perfect square over here will give you 72, you would get 36 times 2. And then you can simplify the square root of 36 is the number 6, and then you're left with the square root of 2. Now, you could have done 9 and 8. So if we were to go down here, 72 does simplify into 9 times 8. And the square root of 9 is 3. However, the problem is the square root of 8 itself also has a perfect square. The square root of 8 has a 4 in it. And so you would have to simplify it again. Square root of 8 is square root of 4 times the square root of 2. The square root of 4 is the number 2. And 2 times 3 is how you would get 6. So the best way is if you can find the largest perfect square that will go into 72, then that would help you to simplify the easiest or the fastest way. The square root of 20, you could simplify into 4 times 5. You cannot do the square root of 10 times 2. 10 times 2 gives you 20, but 10 and 2 are not perfect squares. You have to get a perfect square. The square root of 4 is the number 2. It's not the square root of 2. It's the number, the natural number 2, and then you're left with the square root of 5. Imaginary numbers. There is something called the imaginary number I that is defined as I squared represents negative 1. And so if you were to take the square root of both sides, you would get I is represented by the square root of negative 1, which you have learned in the past you cannot have the square root of a negative number, which is why they have denoted the letter I, represents the square root of negative 1. So the square root of negative 4 is negative 1 times 4. The square root of negative 1 is I, and the square root of 4 is 2. And so your answer would be 2I. Square root of 8 would be the square root of negative 1 times the square root of 8, and we now learn that the square root of 8 is the same thing as the square root of 4 times the square root of 2. The square root of negative 1 is I. The square root of 4 is 2. You cannot take the square root of 2. So to write it in, I guess you would say standard form, it would be 2I times the square root of 2. So something cool that happens with the powers of I is that they actually end up repeating. So the I to the first power, well, I is the square root of negative 1, and the square root of negative 1 is just I. I squared is basically saying the square root of negative 1 times the square root of negative 1. Well, a square and a square root cancel, leaving you just a negative 1 as the answer. It's actually the number negative 1, not negative I, it's actually the number negative 1. I to the third is I squared times I. Well, we know that I squared is negative 1. So negative 1 times I is just negative I. I to the fourth, you can say, is the same thing as I squared times I squared. Well, we know that I squared is negative 1, and we know that I squared is also negative 1. And so negative 1 times a negative 1 is a positive 1. So if you kept going, I to the fifth is I to the fourth times I to the first. Well, we know that I to the fourth is 1. So 1 times I is just going to give me I. So if you notice, I to the fifth is the exact same answer as I to the first. I to the sixth is I to the fourth times I squared. Well, we know I to the fourth is the number 1. And we know that I squared is negative 1. And so we get negative 1. So if you notice, I to the 6th and I squared are the same answer. I to the 7th would be I to the 4th times I cubed, because 4 plus 3 is 7. I to the 4th, again, is the number 1. And then I to the 3rd is negative I. So 1 times negative I is negative I. So if you notice, I to the 3rd and I to the 7th, again, are the same one. So what happens is every fourth exponent is going to repeat every 4 times. So I to the 5th, the same thing as I to the 1st, I to the 6th, I to the 2nd, I to the 7th, I to the 3rd. So if I did I to the 8th, it would be the exact same thing as I to the 4th. So the way you do it is that since every multiple of 4 repeats, you could say, okay, well, 4 goes into 21 5 times perfectly, and you're left with 1. So I to the 21st is the same thing as I to the 1st. Whatever the remainder is, that's your actual exponent. And so I to the 1st is I. 94, same thing. 4 goes into 94. 2 times, that's 8 with 14. 4 times 2 is 8. Subtract 1, 14. 4 goes into 14. 3 times to get 12. You subtract, and you're left with 2. So the remainder is your exponent. So I to the 94th is the exact same thing as I squared, and we know that I squared is negative 1. And so I to the 94th is the answer, negative 1. Complex numbers are written in the form of a plus bi, where a and b are real numbers, okay? But I is attached to the b. That is the imaginary part. The a is a real part, bi is imaginary part. So for example, if I want to simplify this, square root of 20 would be the square root of negative 1 times the square root of 4 times the square root of 5. The square root of negative 1 is I, square root of 4 is 2, and you cannot take the square root of 5. So this form right here would be 2I square roots of 5 minus 8. Now, the real part came first, so we would just swap it. Negative 8 plus 2I square root of 5. You also can add and multiply, subtract and divide actually complex numbers. So we can distribute this 2. So we'll get 4 plus 3I minus 10 minus 4I, because 2 times 5 is 10, 2 times 2 is 4I. The 3I and the negative 4I combine, and the 4 and 10 combine. So 4 and negative 10 give me negative 6. 3 and negative 4 give me a negative 1I. Make sure that I goes second. You also can multiply complex numbers, but in this case, you do need to be careful that when you multiply i's together, it is possibly going to change its answer. So 4 times negative 2 is negative 8, but I times I is I squared. And you have learned from previous that I squared is the number negative 1. And so this is negative 8 times negative 1, so your answer is actually a positive 8. The i's actually go away. You can also FOIL. So 5 times 3 is 15. 5 times negative I is a negative 5i. 2i times 3 is a 6i. And then 2i times I is a negative 2i squared. Negative 5i and a positive 6i give me a positive 1i. And then if you notice, this right here actually can be combined to become a real number. We know that I squared is negative 1. So negative 2 times negative 1 actually turns into a positive 2. So 15 and 2 give me 17. So our answer is 17 plus I. Same thing here. 3 plus 2i, quantity squared, means that you write this factor, this expression, twice. So when you FOIL, 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is also 6i. And then 2i times 2i is 4i squared. 6i and 6i combine to give me 12i. But remember, I squared is negative 1. So 4 times negative 1 is negative 4. 9 and negative 4 give me a positive 5. So my final answer would be 5 plus 12i. Using that, what we have learned about complex numbers, imaginary numbers, we can now solve equations even if they are not going to have real zeros. For example, this x squared is only in one term, which means we can actually solve for x. So the way we would solve is we would first subtract 100. So we get 4x squared equals negative 100. And now to solve for x, we would divide both sides by 4 because we need to get x squared by itself. Negative 100 divided by 4 is a negative 25. So now we can actually take the square root of both sides. Don't forget, when you take the square root, you would get a plus or minus. So do not forget the plus or minus. You should get two answers. And the square root of negative 25 is 5i. And those would be your answer. 5i and negative 5i would be your answer because negative 25 is the square root of negative 1 times the square root of 25. Square root of 25 is 5, and the square root of negative 1 is I. Same thing here. You have to solve for 0, so I'm going to subtract x squared on both sides. And I'll get 2x squared plus 1 equals negative 1. And now I'm going to subtract and get negative 2 when I subtract 1. And now to solve for x, I have to divide by 2. So when I divide by 2, I'll get negative 1. That is equal to x squared, so you're going to take the square root of both sides because the square root and the square cancel, leaving me x equals plus or minus, and then the square root of negative 1 is the imaginary number I.